So this is going to be the solution for recitation problem number 2. And here we're given an equation. I'm going to change the equation slightly so that it's not exactly the same as the recitation problem. So we're told that we're given a position of some particle, and okay, so let's make up some numbers. I'm going to start using standard units, so this will be, let's say, 17 meters times sine, and I'll say it's 3.2 t. So we have an equation, right, that's 17 sine t, where part A is asking, so roughly, if I had to draw the graph for this, right, so it's roughly, sine starts always from the origin, so it's a periodic function like this. So I have a rough idea what's happening. So our horizontal axis is time, and our vertical axis is the position of the particle. Okay, so first part, we're going to find the time period of the motion. So here we go. So this is sine 3.2 t, and I have to calculate the time period t. T is the capital time period. Now, to solve this problem, right, the basic idea is you ask yourself, right, I know that this function, 17 sine of 3.2 t, is exactly the same value if I shift by a time period t, because the function is periodic of time t. So this must be the same equation as sine of 3.2, but a time period t. Hopefully you saw that, right? So this function, the values of this function and this must be identical because it's periodic with a time period t. Once I know that, right, I know that the next time period, right, must occur 2 pi units later. So I know that 2 pi in radians, right, 3.2 t plus 2 pi, the period. Sine functions have a period, sine, cosine functions, they both have a period of 2 pi. So I'm expecting that the sine function repeats itself. So the only way this angle that's passed to the sine function, right, could be the same as this is that this angle and this are deferred by 2 pi, which means that 3.2 t plus 2 pi must be this angle, because we added 2 pi radians to get to here. So this is 3.2 times t plus t. And if you expand this out, 3.2 t plus 3.2 t, and there's a 3.2 t here, plus 2 pi. And so we can cross this out, and then we have 2 pi is equal to 3.2 t. So 3.2 t is equal to 2 pi. And so what's the time period? It's 2 pi over 3.2, which is here. So remember, this is actually the angular velocity, but I didn't even mention that at all. But it's 2 pi over 3.2. So let me bring out my calculator, which I just happen to have. So it's 2 times, oh, there's no pi in this, so actually there is, times pi divisible by 3.2, and I get a value of 1.963, and keeps going. And the first thing you should do is look at the number of significant digits you have. We have 2 significant digits for these numbers, so we should only keep up 2 significant digits. In this case, right, we round up 6, right, to the next highest value, so this will be 2.0, and the standard units is seconds. So this is the time period. Okay, great. Now let's do part B. Part B asks the frequency of the motion. So what's the frequency of the motion? So if you remember, frequency is just the number of times something happens in a unit of time, in one unit of time. In this case, it's 1, divisible by that time period, which in this case is 2.0 seconds. So 2.0 seconds. So we have now 0.5 hertz. Okay, it's standard units of inverse seconds. So the standard units is in hertz, so we finished part B. Part C asks, what is the amplitude of the system? So do I have enough space at the bottom? Yeah, let me just finish off C. The amplitude of the system, right, must be the maximum displacement from the origin, from the center. In this case, it's 17. So the amplitude is 17. Standard units is going to be in meters, so it's 17 meters. The actual problem had units already in there, but I always put the units at the end. I don't usually put them in equations. Okay, so part D says, so you're starting at time t equals 0. Find first time to reach, and I'll make up numbers, so let's say 5. X equals 5 meters. Okay, so we're starting from the origin at t equals 0, and then we're going up and reaching a certain point. We have to calculate t. So basically we have the original equation, x 17 sine of 3.2 t, and I can put 5 in here, so I'm solving 17 standard units sine of 3.2 t, and I'm solving for t. So I'm going to divide by 17 both sides. I'm going to move the 17 to this side, so now 5 over 17 equals sine of 3.2 t. And then I'm going to take the inverse sine of 5 over 17, so that's actually arc sine of 5 over 17 is equal to 3.2 t. And I will divide on this side, so this is 1 over 3.2 times arc sine of 5 over 17. And that's equal to time t. So what is t equal to? And I'm just going to plug it into the calculator. Now, just be careful, because your calculator by default, right, is usually in degrees, and so you have to make sure that your calculator is in radians. So hold on a sec, let me shift to radians, because all of our calculations we're going to be working in radians. So hold on a sec, shift, not 4. Okay, I'm in radians. Okay, so I'm plugging in, let's see, 5 divided by 17 equals, and then I'm going to say in arc sine, so shift inverse sine. Messed that up. 5 divided by 17, shift sine, okay, and divided by 3.2 gives me, okay, cool. Okay, I get 0.09, and there's 2 single digits, so I'll leave it up to 3.3. So this is in seconds, right? So multiply by 100 divided by 100. So this is multiplying by 100 will give you 9.3 times 10 to the minus 2, because we're writing it, seconds. So we're going to reach that pretty darn quickly in 5 meters in 9.3 hundredths of a second. Now let's just double check. It's in 2 seconds. Oh, kind of does look a little bit small, doesn't it? Arc sine 517. And yeah, I guess it's 9.3. Actually, or you could multiply by 10 and divide, so it's like 93 milliseconds. 17, 3.2. Anyway, this is the solution for problem number 2.